It's my great pleasure to introduce a friend and a leader at the U.S. Army Corps of Engineers. He's a senior scientific technical manager of materials manufacturing structures at the ERDC, the Engineering Research and Development Center for the Corps of Engineers. Dr. Mosier is the senior scientific technical manager. And as part of that, he oversees programs, strategy, collaboration, and capability development in the areas of materials, manufacturing, and structures for military and civil work programs at the U.S. Army Corps of Engineers Research and Development Center. His portfolio covers a range of topics in materials and manufacturing science, built and aging infrastructure, and military engineering applications in force projection and protection. Dr. Mosier's efforts also leverage many interagency R&D partnerships with industry and academia to support the ERDC mission. It's been we've been working for more than a decade and a half with the U.S. Army Corps of Engineers. They're true innovators. And at the top of that, of course, is Reed Mosier. Please help me provide a very nice and warm welcome to Dr. Mosier.
Good morning. So thanks again for the opportunity to come. It's always good to come to the University of Maine and see some of the amazing work, the amazing facilities, and to get to learn about some of the other partners here at the center too. So I'm excited about that. So Habib gave me a good introduction, and I'll try to run through some of this introductory content just to keep us on time. The nicest part about coming to Maine right now is that for the last month where I live, it's basically been over 100 degrees every day. And so when I got here last night and it was a rainy 65 degrees, that was a very welcome change in climate. So I appreciate that opportunity as well. So I thought I'd give you just a high level overview because, you know, what I was asked to do and in the context of this meeting is talk about how do we bring research into practice. Bringing research into practice is complicated. And at least in our portfolio, it's driven by stakeholders, it's driven by strategies and customers. And so, you know, giving you some introductory content on what are some of the mission sets and some of those stakeholders that really drive how we try to do business in our research and development portfolio. So in the Corps of Engineers proper, these are the 6 main mission areas for project delivery for the nation. About $100 billion portfolio this year, typically more heavy on the military side, but we see reinvestment in infrastructure and modernization of infrastructure. So about half of that today is in civil works. So the things that I think a lot of the American public thinks of when they think of the Corps of Engineers with dams and levees and hydropower facilities and those types of water resources infrastructure projects. Typically, our bigger portfolio is on military construction for the Army, the Air Force, and also in some cases supporting the Navy as well. At our installations here at home and around the world, and I'll show you some examples of that. Beyond that, our Chief of Engineers, and I'm going to show you some examples of this because I think we have a lot of great examples, many in partnership with the university, in fielding things to the warfighter. So outside the fence line in the potential theater of operations, our Chief of Engineers also wears the hat as the commander of the engineer regiment. So that's another 100,000 or so active duty combat engineers that do bridging, they take down obstacles, they build fortifications, all types of, you know, civil engineering and infrastructure centric things that we do to support how the Army and the Joint Force operates. We sit down in the research and development mission. And so, you know, our mission is basically to support all of these missions of the Corps of Engineers and more broadly, the Department of Defense on any types of challenges that fit into our competencies. Oh, wow. That was a lot of slides. You're getting a preview. All right. So where do we sit? So, you know, the Army is a complicated R&D enterprise. There's 4 science and technology laboratories in the Department of Defense: ERDC, Army Research Lab, Air Force Research Lab, Naval Research Lab. We sit within the Department of the Army and under the Army Corps of Engineers. And so we have 7 different laboratories within the ERDC, about a $2 billion portfolio. The competencies of those laboratories, which are kind of equivalent to the colleges, I guess, at a university, are pretty self-explanatory based on their names, right? And so, you know, the way we see ourselves, and I think this is, again, is important for transition, is at the center of this, I guess we'll call it a flower, you know, we have our competencies, we have our people and capabilities, right? Those people and capabilities support research programs, and those programs are aligned with strategies. And those strategies are developed by different stakeholders that have different requirements, different transition pathways, right? And so everything that we do is driven by that. We do have a small basic research portfolio that may be akin to, say, NSF style work, scientific discovery and knowledge generation. But most everything that we do, like most of the stakeholders you all work with in the Department of Transportation and other agencies, we have a vision for how we want to use that technology. There's a tangible requirement. No matter how fundamental it is, the long range plan for that is we want to implement and leverage that technology and move it into practice. And so we do that in alignment with 10 different research and development priorities. If you look across the portfolio, and probably if I came here maybe 5 years ago, we'd say, well, this is what we're doing for the Army. And this is what we're doing for Department of Transportation. And this is what we're doing for DHS. Our Chief of Engineers at this time, Lieutenant General Spellman, is, I would say, the biggest champion for technology and innovation we've ever had in the Corps of Engineers. And so he said, if I really want to make research and development a priority mission for the Corps, I want to look across all these stakeholders and rise up and kind of what are the cross-cutting priorities that we need to focus on as a command moving forward. And so that's the development of this R&D strategy. It was released in 2021. That QR code actually works. I tried it before I came here because sometimes those things don't work. And these are the 10 different priorities. Some of these are things we've worked on for a long time and we're going to continue working on, around warfighting functions and infrastructure and environmental problem sets. Some of these are new emerging requirements, the intersection of cyber and physical security, data analytics, climate. So these are things we need to start focusing on as an agency to address priorities in the Department of Defense and priorities for the nation. So I'll highlight some of the civil and military aspects of some of those requirements. So in the civil workspace, this is where we're going, right? So it's everything from data analytics and AI to ecosystem restoration and threatened and endangered species, but infrastructure. Right, we have a huge portfolio of aging infrastructure. I think it's on the order of just capital stock value, about $1 trillion replacement value for that infrastructure. And we maintain that infrastructure with single billions of dollars of appropriations, right? And about half of that goes to dredging. So I think if you do the math, it's like less than one oil change every 5 years for a car. That's the amount of money we have to maintain our infrastructure. And so rebuilding that infrastructure is challenging as well. One major lock and dam project, we just finished one and opened one on the Ohio River, the Olmsted Lock and Dam project was $3 billion, right? So we're not going to be able to afford, no matter how many infrastructure bills we get passed, we're not going to be able to afford to replace all of the assets that are already at an average beyond their design service life. So we got to make that infrastructure last longer. We got to make it more reliable for our economy, and we got to make it resilient for the natural hazards of the future. And so that's really where we're going with infrastructure. And I think it's in good alignment with the priorities, the thrust areas you have here in the center. We want to understand what's going on. We want to predict the future. We want to shape the future with new technologies. And a lot of that's materials manufacturing, sensors, things of that nature. In the military area, typically about 75 to 80% of our research portfolio is focused on military applications. Infrastructure is critical to this as well, right? And we increasingly see that when we think about the types of conflicts we might have in the European theater. We see what's happening on the news every day in Ukraine and how infrastructure is critical to everything happening there. We think about how we might fight in the Pacific, right? And so, I think those warfighting concepts rely on infrastructure and logistics and supply chains more than we've ever thought about before, right? We have adversaries that can hold our facilities at risk all the way here in the homeland. The homeland's not a sanctuary. And so if we have to deploy to the Pacific, we have to get from, an installation here in the United States or a manufacturing depot or something of that nature to, let's say, the Marine Ocean Terminal at Concord in San Francisco Bay, go across the Pacific somewhere, maybe to Hawaii or Guam. And then we got to move things around. That's rail, that's airfields, that's ports, that's bridges, all of the critical infrastructure nodes that move us around. And then once you get into the theater, you've got to move around and use infrastructure there as well. And so the analogy I like to make is we talk a lot about Army modernization or DoD modernization. You see new fighter jets and robotic tanks and all of these things. They're pretty useless if they don't have a place to land and take off from, or we can't get them off of a rail car or even out of the port here at home to get to where they need to go. So these kind of critical enabling technologies they're critical for us to fight and win in these future theaters. All right. And so how does that play into infrastructure? Oops. You go back let's see, there. All right. I like to highlight this civil and military because this is infrastructure, right? I think a lot of people think of the DoD as war fighters and weapon systems. I kind of think of the DoD as a huge infrastructure and logistics agency that happens to own a lot of widgets and have great soldiers, right? Because that is what enables us to do everything. And so if you look at on the military side, 800 installations, hundreds of thousands of facilities, hundreds of thousands of other infrastructure assets. And in the federal government, the Army is actually the biggest holder of buildings. So we have a big drive there, especially, you know, in the recent times around even things like sustainability. Can we use the buying power of all of these buildings to change markets and move forward in aspects like sustainability and resilience, just as one example. On the civil side, I talked about some examples there and those unique infrastructure projects that, you know, we can't afford to replace, we have to make last longer. And so these things certainly affect our communities. Right? You look at a typical community and they have flood protection assets and navigation assets and bridges and dams and all kinds of things that enable the function of that community. But again, in the context of the military mission, all of that is enabled by infrastructure as well. So whether it's force projection and utilizing ports and airfields and rail systems to get into the theater, in the theater, how do we ensure survivability? Well, it's with fortifications and hardened structures and perimeter security, right? So all of that is reliant on infrastructure as well. Let's see. All right. And so I'm not going to go into this in detail, but this will give you kind of a highlight of some of the areas that we're focused on in infrastructure, materials, manufacturing, a lot of the things that, you know, I think there's good connectivity to the work you're doing here in the center. The top two areas really in the warfighting function, how do we improve levels of protection with advanced materials and advanced structural designs? A lot of that is, again, how do we upgrade existing structures? Right? We have a lot of structures around the world that were built after World War II that we're not going to be able to afford to replace. And there's all kinds of new threats and adversaries that face them. So how do they even perform? Force projection and maneuver, that really gets into the transportation and infrastructure space and a lot of connections, I think, with the center and other things that your universities do, right? In forward manufacturing, lightweighting, modularity, all these things that are going to reduce logistics for the projection mission. And then that third area is really around permanent enduring facilities and infrastructure. So that brings in aspects of, you know, durability, sustainability, energy performance, all of the things that we think about there. And so I wanted to talk a little bit about the topic of today is getting research into practice. And so I pulled this is from the Defense Acquisition University. It's a big 1,000-page book. And they say, this is how you do technology transition. It's a very linear process, right? We do basic research, we do applied research, we demonstrate technologies, we come up with a manufacturing industrial base, we do doctrine, and then we operationally deploy that, right? And so just like, you know, people say you're gonna climb the corporate ladder in your career, we should be able to do that with transition. But when I talk to a lot of folks, and in my experience, transition looks a lot more like that, right? It's a jungle gym of all different kinds of things, all different colors of funding, all different proposals, all different kinds of spin-off applications, and all different kinds of customers. So, you know, when you hypothesize how your technology is going to be used or connect with a stakeholder on what it's going to be used for, you know, you have a target. You might get to that target, but you'll probably have a lot of other tertiary targets along the way that generate value from that research investment. And so I want to show you some examples of how complicated that can be, and some of the ways we try to think about that in our programs. So this is a complicated chart I'm not going to go through in detail, but at least in the Army, this is what my director likes to call the transition wheel of fortune. So these are all the different ways that we transition technology through the R&D program, right? So examples, let's say over there on the right, geospatially enabled operational design. It's a bunch of fancy words. Basically, you know, your commanders in the theater have geospatial tools that allow them to understand the operational environment, right? And it's up to their training and their intuition to say, well, these are the things that I see. I need to do this. This is what I'm going to do, right? With an advanced adversary, that is all happening so fast that your cognitive ability to do that is limited, right? So can we use AI? Can we take that doctrine and put it in a virtual space and virtually come up with courses of action that they can rapidly run through to come up with the most optimal decision, right? So a transition in that space is fairly straightforward. We do research, we develop a tool. All of our commanders use something called the command post computing environment. So it's basically like the Google Maps for commanders. We put that as an add-in to that, and this little window will pop up and say, this is kind of what's going on. These are the things we think you should do to achieve your objective, right? So it's a very direct transition pathway. This example up here on the top left, this is probably more similar to a lot of the transitions that are pertinent in infrastructure, right? So this is a recent conflict, at least unclassified. If you want to Google, there's a good 60 Minutes special about the bombing at Al Assad Air Base. And so we have a series of protective structures across the Central Command, across the Middle East, originally designed for smaller rockets, artillery, and mortar and fragmenting weapons. And our adversaries are shooting ballistic missiles at those now, right? And it's causing traumatic brain injuries and all kinds of injuries that were never anticipated. So we do research to address that, right? Come up with proposed design specifications. How do you transition that? Well, we're not going to contract with Northrop Grumman and say, well, send me 10,000 of those bunkers. It's going to go out as specifications and a design package that's going to be awarded by a district to do retrofits of those in the theater, right? So that's a transition that's similar to what we may do in the construction industry. We're generating knowledge, and that knowledge is translated into design, right? And so that's largely what we're doing in the case of construction and infrastructure, right? We're doing discovery, coming up with new things, but those things are generally transitioned in building codes and standards and specifications. So we do that in the civil portfolio. We do it in the DoD for our military portfolio and military construction. That becomes complicated because in the DoD, all the services also work on this. So it really doesn't even matter if the Army thinks it's great. Generally, to get it in the book, the Air Force and the Navy have to think it's great too. And so that can be challenging. Education and training, of course, and then something I know you all are very well aware of, and I like to give the example is transition in this space is maybe not as technologically complicated, but about more relationships and teamwork more than probably any other industry I could think of, right? And so, if we have an iPhone, we can make a better iPhone. There's awesome technology in it, but they manufacture it, they sell it in their store, right? If I come up with a new technology in the construction industry, we got to have policymakers that want it and will fund it. We got policymakers on the back end that will implement it on the way that we actually pay for projects. We got to have practitioners up to speed to use it. We got to have the construction labor workforce that understands how to use it. And so there's all these barriers, things that we got to get people up to speed. And so that is it's a challenge in that space. And so an example of that jungle gym, and I'm not going to go through all these acronyms because I don't even know what all of them are, but this is how complicated even the military construction space things can be for research and development to get new technology in. And so I'll show you, kind of the different functions of this and then examples of how we actually do it. So you got folks up here in the top left quadrant. These are the people that write the strategies and policies, and they generally own the money, right? You got people in the right. Those are the people that actually run the stuff. Those are the owners, the commanders, the people that are gonna say, I really need that in my projects. I want to respond to policy and strategic requirements, invest in that technology and put it into my program. Then we got all the people that do research. We do research at ERDIC, y'all do research, national labs do research. How do we integrate that? And then we've got different groups of transition partners, right? And so I see this is kind of like a closed circuit. If I take one of these components out, I might as well not do any of it. So we got to have policy people agreeing. We got to translate policy into real requirements. We got to have R&D people that can understand those requirements and generate a product. And we need to identify folks to transition that product to. And so, I live and breathe this every day. And to me, it's still very confusing. And so I wanted to show you kind of an example of how we're doing this, at least in the Army portfolio. And so the little graphic there on the top right, I think is critical because at some level, everything's about relationships at the researcher level and program manager level. But if we can facilitate success through policy, that's something that I really push for, right? Because we want to make sure that if we're investing in research, the policy makes sure that that research is going to be transitioned and utilized. Otherwise, we're just generating knowledge for the community, which is great. But is that the most efficient use of our resources? And so we need to balance the push and pull of that technology. And so one of the ways we do that in the Army is through our transition policies. So if you're going to propose applied research and technology demonstration kind of activities, you can't even propose them and you can't even get funding unless it's signed off for with agreements by a transition partner. right? So somebody that says, I'm gonna take that baton at the end of the race and I'm gonna pull it over and I'm gonna do the training and develop the industrial base and put it into my portfolio to buy it or specify it or whatever. And so this is an example of doing that in the structural hardening technology. So, you know, in the Army Modernization Strategy, National Defense Strategy, we talk about we got to modernize for advanced adversaries, use better materials, use structures that are more resilient, reduce our vulnerabilities. Most of the folks that own that are in Big Army. Big Army owns the research and development investments, but that transition is owned by the Corps of Engineers itself, right? And so we got two separate organizations, actually multiple organizations driving policy, owning the funding, owning the requirement, and then they own the transition. And so we execute the research and development at ERDC, but all of that is managed through transition agreements. So these are not, you know, just handshakes. These are like policy that's implemented that says, this is what we're going to do. We're going to develop this technology on this timeline and we're going to hand it off. And what that transition agreement allows is the stakeholder, in this case, the Corps of Engineers, because the Corps of Engineers is going to, I don't know what happened there, but update the building codes and specifications to adopt that technology. And so all that's established in transition agreements. And so this is, you know, the kind of model that we like to do to establish who's going to do what, not just from a researcher's perspective, but from the whole technology innovation life cycle. It's really complicated and nobody likes to do it, but you have to do it for success, right? And in our case, we have to do it because you couldn't even get the funding to do the research to begin with if you didn't. These are other examples of different transitions. I'm not going to go through these for time's sake, but just to give you some examples of different types, you know, sustainable materials and bunker mitigation. Those are things that, you know, we're doing research on, and we're going to adopt that through codes and standards and specifications, right, for industry to support the government on. These examples here on the left are a little bit different, and I know here at the university you do a lot of work in this space, you know, developing different kinds of technology that generally results in IP, and then that IP gets picked up by industry to generate products to sell back to the government through an acquisition program. So there's all kinds of different transitions. I won't go through these in detail. A couple of the examples I put in here is I did want to highlight, this can take a lot of time, right? So you may have a clear timeline on your project, but when you look at the real impact, it can take a long time. This is an example I actually pulled from a recent chart, and I think Dr. Landis can appreciate this because this is from research investments about 20 years ago with Professor Bazan. So basic research investments on damage models for concrete and rock mechanics, where we wanted to modernize weapons effects codes. Basic research moves into applied research, gets demonstrated in different codes, gets validated by field experiments. And these today are in production level codes that non-expert users are using all over the DoD. Other examples in, say, polymers, examples for airfield damage repair. Again, basic research investments. We wanted to look at foamed polymers and expandable foam so you could rapidly fill bomb craters in airfields, right? Rather than using conventional concrete and flowable fill. So could we do that and get up to strength in, you know, minutes or something, do a hard capping and with the main requirement of being able to operate the airfield in less than 2 hours, right? And so these systems invested through basic research to develop the material and manufacturing process, through applied research and industry partnerships to get that technology into a more practical state, demonstrated through capability technology demonstration programs, and then finally adopted. And these are in airfield damage repair kits that are deployed all over the world for whatever conflicts might arise. And so my closing thought here is kind of circling back to what I started with. I think a lot now from a program management and business perspective, and people ask me a lot of questions about the value of R&D and the return on investment, right? And I know a lot of us that are in government positions, we hear that a lot, right? Because it's really easy to understand if I build a levee, this is the value that's generated. It's hard to understand if I make an investment in research, the broader impacts, that's hard to quantify. And so we're often thinking about, you know, well, how's the sponsor going to apply that? Or how could maybe my technology be used? The one thing I really like to stress externally and even internally to our researchers, all the other broader impacts that come out of research and development. You know, just like I said, the jungle gym, there may be one target that you're moving towards, but there's all other kinds of spin-off applications, the knowledge that's generated, how it advances the community, how it advances the workforce and the economy. the value of R&D, I think, is endless. So I would just put that out there as kind of a closing point. But I thank you all very much for the opportunity to come today and talk. It's always great to come up here. With that, I'll hand it back to Habib.